Okay, so what would you do if you had a problem like this and it was going on about wanting to find the principal um, angle of stress and the maximum amount of stress that you got and the maximum amount of shear stress you got and stuff. So this is our stress state and the values I'm going to use is I've shown my stress state so that I'm assuming everything is in tension and rotating normally uh, with the shear, and so I am going to examine a problem that's in actually compression. So I'll put a minus here. So I should point out that normally when you see stress states like this, you'd probably have the 55 and the arrow pointing inwards. And I'll put another compression here. So normally my Y would be pointing downwards, and this 85 would be a positive number. And then our shear stress, it can be 30 megapascals. And let's say the question was um, that we want to find the um, the principal angle of stress. We want to find the maximum stress value, the minimum stress value, and the maximum shear stress value. So these are normal stress values. So what we're going to do, obviously we're going to grab our formula sheet and have a look at it and see if we can spot anything here that might be useful. So anything here that grabs your attention that you might want to use. So I think it's going to be, this is going to be for the principal angle. This will give me my maximum and minimum stress, and this will give me my shear stress. So let's cut and paste these guys here. Right, so they are my equations that I want to use. So, principal angle stress. Well, first of all, what is that? It's the angle where if I rotate my x-axis, I can then start pointing it, assuming that x was actually the maximum amount of stress, which it's not actually in this case. It would be the angle that I'm going to rotate my axis such that I'm going to get the maximum amount of stress pointing off in that that angle. And then if I add on another 90 degrees, we'll get the minimum angle. So where the principal angle of stress is pointing, that direction will be related to the maximum. And if you add on 90 degrees, you end up with a minimum. Where if you rotate your stress state such that it's at the angle of principal stress, what do you think your shear stress is going to be? Anyone get it? It's going to be 0. Let's have a look at this then. So we'll work out what A is first. So tan, that. So 2 times 30. And then we've got x, which is minus 55, take away y, which is minus 85. So let's put this in my calculator. Therefore, 2 theta pi equals 2 times 30 divided by minus 55 plus 85, minus minus becomes plus. And then we want to do shift arctan answer. So that equals 63.435 degrees. Now it's 2 phi that you need there. If you had a negative number, you might want to add on 180 here. In fact, we could probably do that as well. So we could have the option of adding on 180 and then divided by 2. So you can see that you're going to get an angle, theta, which will be the 63 divided by 2, which is going to be 31.72 degrees. So we're kind of going off in this direction. And then if I plus, so 180 divided by 2, so if I plus 90, so 121 degrees from this axis here will give me the other axis. So that's the orientation that I need to do to get the principal stresses. Now let's use this equation here to find what the maximum stress is going to be. So part B. Now, since I've been asked for the maximum shear stress, we notice that this term here and this term here are the same. So I'm going to do the trick of working out this term and this term before I plus and minus them. So max equals, we got minus 55 minus 85 divided by 2. So that's a minus 70 plus, let's work out all this stuff here. So let's start off with a bracket, and we got minus 85, minus 55, minus minus becomes a plus, so plus 85, and then we want to divide that by 2. Then we want to square it. Then we want to add on that squared, which is 30. Then we'll take the square root of that, and gives me something not particularly nice. Plus or minus 15. Well, it's okay to write this as a irrational number at the moment. Okay, so that's going to be the plus. So we have minus 70 plus 15 root 5. And that gives me minus 36 point, I'll do 2 decimal places, 46 megapascals. Let's look at the minimum one. So we're just going to use the previous one, make it a minus. See, you notice how this is minimum in a negative sense. It's not minimum as in terms of magnitude. So minus 70, I think I've done replay there, minus 15 root 5. So that's the bigger number, 103.54 megapascals. Okay, right, so min max, and then for our shear stress, we can just state that number from above. So that's part C, part D, shear stress equals whatever that is. So that is going to be 15 root 5. So that is going to give me, the positive one will be 33.54 megapascals. And is there anything I want to do there? But the last thing that you could do as a little check, I suppose, is you could use one of your transformation equations. And you could check whether it's transforming correctly. So let's use our transformation equation. And we are going to say our original stress values are minus 55 minus 85 over 2 plus minus 55 minus minus becomes a plus 85 over 2, and we're going to transform it that angle. So cos, we've gone, we're going to be pointing this direction, so we're going to go anti-clockwise by the 31.72 degrees. So cos 2 times 31.72 plus 30 sine 2 times 31 point, what's the angle again for 72? And what do we get there? Let's give it a go. Minus 55 minus 85, divide that by 2, plus minus 55 plus 85, divide that by 2, times that by cos, times that by cos, so I want 2 times by 31.72, close it, plus 30, times that by the sine, 2 times 31.72. And what does that give me? It gives me minus 36.46 again. So there you go. So we've done a little check there as well. So if I rotate it by how much is it? I rotate it by the 31.72 degrees anti-clockwise, I'll be pointing at my principal angle stress, and I will get those values. The last thing you could do is you could say, right, well, you told me that if you're pointing at the principal angle stress, that your shear stress will become 0. So is that true? So shall we check that? Well, we've run out of space, but let's do that. So we're going to take this equation, there we go, can take that one, and we're going to take our previous answers. So that's minus 36.46. Is that right? Yeah, 46. And the, I should call that dash, shouldn't I? Y dash. And that's going to be minus 103.54 megapascals. Now, if it's pointing at the principal axis, it should be that this one, whoops, shear stress equals 0. So does it? Let's give that a go. So we've got minus 36.46. Minus minus becomes plus 103.54 divided by 2, all squared, plus 0. So it's my final check. Notice something here. We're square rooting a square, so it's just going to be minus 36.46 plus 103.54. What's that going to go? So minus 36.46 plus 103.54 divided by 2. And that gives me an answer of 33.54 megapascals. And if I go back to my previous page, I had 33.54 megapascals. That is magic.